Hi, seventh graders. So we ended 2017 by looking at the distributive property, and then we're going to recap that, and then we're going to move into what's called factoring. So some of you are testing out another way to look at lessons. You're going to be doing this video lesson. So just some reminders as we go through this lesson today. So you're working at your own pace. So if you need to pause the video so you can copy something into your notes, you're allowed to pause it. You can also rewind to hear something again or see a step-by-step process once again before moving on. So keep those things in mind. So Lesson 3 got into the idea of handing out multiplication. So if you look at letter A here, I want 2 copies of x plus 5. So according to the order of operations, we're supposed to do the operation in the parentheses first and then multiply it by 2. The problem is x and 5 are not like terms. You can't put them together. So we started something like this using what we call the area model. I want 2 copies of x and positive 5. So 2 times x was 2x. 2 times 5 is 10. So the product, the answer to that multiplication, is 2x plus 10. So we started with the area model, but then we got into, I can just do 2 times x is 2x. 2 times positive 5 is positive 10. So if I do that for letter B, I can draw it out again, make 3 copies of x, right? And then 3 copies of positive 4. That's going to give me 12. If I skip to letter D, okay, the only difference in letter D, I still have to do the operation in the parentheses first. The other two were both addition. This time it's subtraction. Can I take 3 away from x? No, they're not like terms. So I'm going to hand out 7 times x 7 times. And then 7 copies of negative 3 is going to be negative 21. So if you look at the rest of this table, the rest of this table has the answer, the product. When I multiply in letter E, here's the answer, 5x plus 3. So I'm going to go back to that area model. This time I know the answer is 5x and positive 30. How do I figure out what I multiplied to get that? Well, let's look at this. 5x and 30. Well, if I look at the numbers, 5 and 30, they share a factor of 5. So if I'm making 5 copies, what am I making 5 copies of to get 5 x's? Right? X 5 times is 5x. 5 times how much is this answer of 30? Right? 5 times x is 5x. 5 times 30, 5 times 6 is 30. So this one, I multiplied the factors of 5 and x with a positive 6. Right? 5 times x is 5x. 5 times 6 is 30. Look at letter G. Letter G, again, I have the answer. What did I multiply to get this answer, this product, the answer when I multiplied? So again, if I start with the area model, I have 3x and I have a negative 12. Let's look at 3 and negative 12 are both numbers. 3 and negative 12, they share a 3. Their common factors are 3. So I made 3 copies of what to get 3 x's? I must have made 3 copies of x. 3 times something gave me a negative 12. Well, if 3 is positive, this has to be a negative because multiplying is about matching, and if they don't match, I get a negative. I know that 3 times 4 will give me 12. So for letter G, I must have multiplied 3 times x minus 4. Right? 3 times x is 3x. 3 times negative 4 is negative 12. So to get this product, I multiplied these two factors. Okay. At the bottom of that same page on page 22, the directions say rewrite the expressions as a product of two factors. So what did I multiply? What two things, what two numbers did we multiply? Now, multiply. Now in the last set of examples, it's easier to figure out the GCF, the greatest common factor that the numbers shared. If you look at these ones, most of them, the numbers are a bit higher and harder to find the greatest one. So Mrs. Zimmer had this method, if you had her last year, and if not, I'm going to show it to you anyway, called the upside down cake. So here's the expression we're starting with, 72t plus 8. All right, 72 and 8. Looking at those numbers, what's the greatest factor you can think of? You might not find the greatest one right away, but what's a common one? A typical answer is 2 because they're both even. So if I take a 2 out of 72, and I have my calculator handy to help me with that, 72 divided by 2 is 36. 36t plus, if If I take 2 out of 8, if I take 8 and divide by 2, I get 4. So there's the next layer of my cake. 36t plus 4. All right, well, they're both even again, so I know I can at least take out a 2. But is there a bigger number that they both share? Well, hey, wait a minute. I know that 4 times 9 is 36. So what if I take a 4 out? 36 divided by 4 is 9, and that guy's got his t, plus 4 divided by 4 is 1. There's the third layer of the cake. 1 and 9 don't share any more factors except 1. And if I'm going to take out a 1 and divide these pieces by 1, I'm left with my same answer. So what did I multiply to get that? Well, I have to take 2 times 4 is 8. And what was I left with? 9t plus 1. So here's the two numbers I multiplied to get this product. What two things did I multiply? What's the product? As a product of two factors. Okay, look at letter B underneath it there. 55a plus 11. So I could do the area model again. I'm just going to go with Mrs. Zimmer's upside down cake as a different strategy. 55a plus 11. Well, they're not both even. I can't use 2. 11 is a prime number. The only way to multiply to 11 is 1 times 11. So can I use 11 times something to get 55? I think I can. 11 times 5 is 55. So if I divide 11 out of 55, I have 5 with an A. 11 divided by 11 is 1. Okay, and again, I have a 1 there, so I'm done with my GCF. There's no other number. So what did I multiply to get this? I had 11 copies of 5a plus 1. And I can always check this, right? 11 times 5a, that's 55a's. 11 times 1 is 11. So we got a little space there. Let's do, so we're not going to do letter D here. Let's try one on our own. Try 24b minus 36. So right now you can pause this video and try this question and then come back, unpause it when you have your answer, and you can check it with my solution. All right, so hopefully you've taken a minute to pause the video and you're back now. So 24b minus 36. Well, let's see. I know they're both even. I can take out a 2. 24 divided by 2 is 12. And I got a negative divided by a positive, so it's still negative. 36 divided by 2 is 18. And I can always use my calculator to check that. 36 divided by 2 is 18. All right, so here's my second layer of the cake. But again, they're both even, so I know I can at least use 2, but there's got to be a better one. Let's see, I can use 4 here, but not here. Oh, 6. 12 divided by 6 is 2. That guy's got to be. 18 divided by 6 is 3, but negative 18 divided by 6 is negative 3. Let's see, the only 3 and 2, I can't go any farther because the only factors for 2 are 1 and 2, and the only factors for 3 are 1 and 3. And if 1 is the only number I can take out, I'm done. So I gave you 24b minus 36. That equals, let's see, we took out a 2 times 6, 12 copies of 2b minus 3. So the directions here said rewrite the expressions as a product of two factors. They could also just say to you, factor the expressions. If you see that, that's what we just did. When we factor it, we're taking out the greatest factors that they share. What do we multiply to get those answers? All right, so if you turn the page to page 23, you go to the part B of exercise 2. It says factor 48j plus 60k plus 24. So I'm going to box in that word factor. Factor this by finding the greatest common factor. So we're going to take out common things until there's nothing left to find what the greatest one was. So I'm going to start with my upside down cake. 48j plus 60k plus 24. All right, those are higher numbers. So yeah, they're all even, and 2 probably will work. And we might start with 2. That's the greatest one I can find right now. And then once I pull a little bit out, I might see a bigger number than, say, 2. But if I start with 2, and I can always use my calculator to check, 48 divided by 2 is 24. So there's 24 J's when I divide out the 2, plus 60k divided by 2. Well, half of 60 is 30k, and 24 divided by 2 is going to be 12. So there's the second layer of my cake here. Well, again, they're all even, so I could use 2, but let's think about it. Can I find a bigger one? Let's see. 30, I could use 5, but that won't work for 24. How about 6? 6 works for 30. 24 divided by 6 would be 4. And 12 divided by 6 would be 2. So hey, 6 works. So again, if I use 2 again, let's do that. Let's say I didn't know 6 was the biggest one and I did 2 again. That'd be 24j plus 15k plus 6. I'd have a third layer of my cake. So if I don't find a greater number, I'm just going to have more layers to my cake. But in the end, we should have the same answer. So this time, let's see, 2 wouldn't work because 15 is odd. 5 doesn't work with those guys. Oh, but 3 works with all of them. So if I did 12 divided by 3, that's 4j's. 15 divided by 3 is 5k's. 6 divided by 3 is 2. There's a third layer of my cake. 5 is a prime number. The only way to get multiplied to 5 is 1 times 5. So we're at the end. So this guy factors to, let's see, 2 times 2 is 4. 4 times 3 is 12. So to make this a very short cake, I should have used 12 first. And if I knew that, I'd have 1 layer to my cake. But this time I have 4 layers because it took me a couple turns. But when I take out all these numbers and take out the GCF 12, I'm left with 4j plus 5k plus 2. And I can check this, right? 12 times 4, that's 48j. 12 times positive 5, that's 60k. 12 times 2, that's 24. When I multiply it back out, I should get what I started with. So here's my factored answer. What I multiplied to get that, 12 is the GCF. All right, we're going to skip to the next page at the bottom again, example number 3. I'll come back to those questions at the top in just a minute. So example 3 says a new miniature golf and arcade opened up in town. For convenient ordering, a play package is available to purchase. It includes 2 rounds of golf and 20 arcade tokens, plus $3 off the regular price. So to make it easy for the workers, you order this package and it will work out the prices for you. There is a group of 6 friends purchasing this package. So as you can see, as I'm working through this, I'm picking out the important pieces of information. G is going to be the cost of a round of golf, so I have to use the letter G. T is going to represent the cost of a token. And my goal is to write 2 different expressions. So 2 different expressions that represent the total amount this group spent. Okay, so option 1. Let's say, what is a play package? What is that going to look like in the computer? Well, it's 2 rounds of golf. They want me to use G for a round of golf. So I have to pay G 2 times. In addition to that, I have to pay T, the cost of the tokens, 20 times. But I also get to save $3. So I'm saving $3. So here's the play package. But there's a group of 6 friends getting this. So all of this is going to happen 6 times for that group of friends. So here's one expression. 2 times the cost of golf plus 20 times the cost of the tokens minus $3 times 6. I could distribute this. So the second version would be 2 rounds of golf 6 times. 6 times 2G, that's 12 Gs. 20 times the cost of the arcade tokens, that's happening 6 times. Well, if 6 times 2 is 12, 6 times 20 is 120 T. They're going to save $3 6 times. That means you're going to save $18. So here's my 2 different expressions. I'm going to use this top one represents a play package 6 times and the cost for each of the individual when I hand out the times 6. If we jump back to the top for a second. Okay, for each expression in exercise 3, write each sum as a product of 2 factors. So multiply 2 numbers. So if you look at letter A, 2 times 3 plus 5 times 3. They both share times 3. So there's 3 copies of 2 plus 3 copies of 5. Look at letter D below it. Again, x times 3 plus 5 times 3. There's 3 copies of x plus 3 copies of 5. I go back to letter B for a second. 2 plus 5 plus 2 plus 5 plus 2 plus 5. I see 2 plus 5 3 times. There's 3 copies of 2 plus 5. Okay, letter E. Again, is there another way to write this? A simpler way to represent this? X plus 5, x plus 5, x plus 5. There's 3 copies of x plus 5. Okay. All right, we're going to turn the page. We're in the home stretch now, page 25. So what is the opposite of negative 6v plus 1? So a common answer that students will tell me is they'll tell me the opposite of each of these terms. So the opposite of negative 6v is a positive 6v. Opposite of positive 1 is a negative 1. And you are absolutely right. In math, there's a symbol that we use for the opposite. So if I want to show the opposite of this expression, opposite is also a negative in front of the expression they gave me. So the question is, who's right? That common answer where you take the opposite of each term, or showing that the opposite, this negative in front of the whole expression. So really, if you look at this guy, we can break this down. This negative is a negative number. What number is hiding there to show that there's a negative there? Okay. Think about, we talked about $1 was $1. If I owe $1, don't I owe $1? So really, there's a negative one there. So I'm going to take that out of that spot. I'm going to write it down in part B. So if I have negative, the opposite of negative 6v plus 1, we know this negative is really a negative 1. Hey, this is what we did right before our holiday break. Negative 1 times negative 6v. Multiplying is about matching, so that's 6v. Negative 1 times positive 1. Multiplying is about matching. They don't match. Didn't we get the same thing? So I can take the opposite of each of the parts of this expression, or I can hand out a negative 1. So look at example 5. Here's where we're going to apply this whole idea of the opposite. Rewrite 5a, I'm going to write it just so I have space, 5a minus a minus 3b in standard form. Justify each step applying the rules for subtracting and the distributive property. So they want me to do this twice. How about I'm going to color code. So the first time I do this in purple, it didn't switch. The first time I do this in purple, I'm going to use our subtraction rule, right? Subtraction is the same as adding the opposite, and then I'm going to do it again using the distributive property. All right, so I'm subtracting a minus 3b. So subtraction is the same. I keep the first term. Subtraction changes to addition. If I take the opposite of a, which really isn't there a 1 there, the opposite of 1a, and the opposite of negative 3b. So rewrote it as adding the opposite, 5a plus negative 1a, different sign subtract, 4a plus 3b. We know that works. Now let's look at that same expression they started with. Let's use the distributive property, handout multiplication. So if you don't like subtraction as much, hey, guess what? This is really a negative 1 getting handed out to a and times negative 3b. So if I do that, I'm not doing anything with 5a right now. Negative 1 times a, negative 1 times negative 3b, that's going to be positive, they match. Don't they? Isn't it looking the same as this guy? 5a, oh, that's a negative 1a, and that's a 3. 5a's take away an a, that's 4a plus 3b. So both strategies work. So when you get to these subtraction problems, you now have a choice. You can add the opposite of this expression, or you can hand out the negative 1. So it's going to come down to a preference. Which one do you like better? All right, so at this point, we're at the end of our lesson. So you're now, you can close out this video and you can check in with Mrs. Almer, but most likely we'll be having you work on the homework, which is on page 26. Looks like number 4, all the parts to number 4. See you later.